Ladder-shaped patch antenna for Ku-band applications. Abstract: in this paper, a ladder-shaped patch antenna for Ku-band applications is analyzed and theoretically presented. FR4 epoxy, Rogers RT/duroid 5870, Rogers RT/duroid 6006, air substrate whose relative permittivities are 4.4, 2.33, 6.15, 1.0006 respectively are used in different combinations and with change in thickness for each version of the design. Parameters like return loss, bandwidth, gain, and VSWR has been analyzed. 3 versions are compared with respect to the above-mentioned parameters. They are designed at resonant frequencies of 14.4 GHz, 14.9 GHz, and 16.2 GHz. Gain is varied from 3.81 dB to 21.84 dB. These antennas are designed with help of HFSS, High Frequency Structure Simulator, software. Proposed antenna has numerous applications in space communication, aircraft and maritime communication, satellite internet, satellite television, etc. Keywords: ladder-shaped patch, return loss, VSWR, gain, bandwidth. Introduction. Microstrip patch antennas are being widely used in various applications due to its compact structure and ease of usage by directly printing them on printed circuit boards. Also, the rigid structure in fabrication of these patch antennas have made them reliable even in adverse conditions. Patches are of different geometric shapes like rectangular, square, dipole, circular, elliptical, and triangular patches. While these being the regular geometric patches, some unconventional patch designs like E-shape, L-shape, diamond shape, etc. are in wide usage due their performance in various parameters according to the purpose of application. These are widely used in wireless communication, satellite communication, space communications, biomedical applications, radars and radar guns, etc. A typical microstrip patch antenna would consist of a substrate, patch which is conducting, and a ground plane. Dielectric substrate is placed in between conducting patch and ground plane, where patch is printed on top and ground plane is printed at bottom of substrate. Patch and ground plane can simply be understood as positive and negative terminals respectively. The design proposed in this paper is ladder-shaped patch, which can be used for the applications in the frequency range of Ku-band, 12 GHz-18 GHz, such as radar guns, satellite television, satellite communication, etc. This was designed with an efficient software tool, HFSS, High Frequency Structure Simulator. 2. Antenna design. Initially, as shown in Fig. 1, a ladder-shaped patch is designed. Combination of substrates, thickness, and type of substrate are varied to show the difference of gain and bandwidth in each version. For all the 3 versions, patch dimensions are constant. Table I gives the dimension values of the proposed ladder patch. A version 1. In the first version, proposed design is placed above 2 substrates FR4 epoxy, which is immediately below the patch, and Rogers RT/duroid 5870 below FR4 epoxy. FR4 epoxy has a dielectric constant of 4.4 with a thickness of 1 mm, and duroid 5870 has a dielectric constant of 2.33 with a thickness of 1 mm. So, total thickness of substrate used in the first version is 2 mm. Fig. 2 shows the design and number of substrates used in first version. Table 2 shows the details of the substrate for first version of proposed design. B version 2. In the second version, proposed design is placed above 2 substrates Rogers RT/duroid 6006, which is immediately below the patch, and Rogers RT/duroid 5870 below Rogers RT/duroid 6006. Rogers RT/duroid 6006 has a dielectric constant of 6.15 with a thickness of 1.5 mm, and Rogers RT/duroid 5870 has a dielectric constant of 2.33 with a thickness of 1.5 mm. So, total thickness of substrate used in THE2ND version is 3 mm. Fig. 3 shows the design and number of substrates used in second version. Table 3 shows the details of the substrate for second version of proposed design. See version 3. In the third version, proposed design is placed above 3 substrates FR4 epoxy, which is immediately below the patch, air gap below FR4 epoxy, and Rogers RT/duroid 5870 below air gap. FR4 epoxy has a dielectric constant of 4.4 with a thickness of 0.75 mm, air has a dielectric constant of 1.0006 with a thickness of 0.5 mm, and Rogers RT/duroid 5870 has a dielectric constant of 2.33 with a thickness of 0.75 mm. So, total thickness of substrate used in the third version is 3 mm. Figure 4 shows the design and number of substrates used in third version. Table 4 shows the details of the substrate for second version of proposed design. 3 results. 4 conclusions. A ladder-shaped antenna have been designed for Ku-band applications using different combinations and thickness of 4 substrates FR4 epoxy, air gap, Rogers RT/duroid 5870, Rogers RT/duroid 6006, and a lump port feed line is used to excite the antenna. By observing results in all 3 versions, return loss is way less than 10 dB, which depict that losses are minimal during transmission. VSWR is nearer to unity in all 3 versions. Gain is more than 3 dB in all 3 versions. Return loss, gain, VSWR, and bandwidth are pretty much good when substrates used are only metamaterials which are less lossy in nature. Designed antenna can be used for satellite communication applications, space communications, radar guns for law enforcement, maritime telecommunication, etc. Acknowledgement. This work was encouraged and supported by Dr. K. Karunakumari, Association Professor, GIT, Geetam deemed to be university, for her stimulating guidance and profuse assistance. We shall always cherish our association with her for her guidance, encouragement, and valuable suggestions throughout the progress of this work.